So good afternoon, everybody, or good morning, everybody. Just to talk about exam one, the overall grades were great for exam one. And I just suggest you keeping the pace in terms of attending the class or watching the class online and reading the textbook, the lectures, taking notes, and also studying groups. And just want to highlight that usually students have more difficulty in the following exams. Like I said, the exam that covers the mortality chapter is the one that the students have more problems with. So just keep the pace, doing the good work, and everything's gonna work out for this course. I will continue now on the chapter about world population changes over time. We covered half of it, and I will continue here in the second half about demographic transition. And just one more thing. There is no quiz today. So the first lecture after an exam, we don't have quizzes, right? So that's how it's informed in the syllabus. So no quiz today, you won't see anything on Canvas. Our next quiz is gonna be on Thursday. So with all these changes that we have been experiencing in terms of mortality decline and fertility decline over time in different populations, demographers start to look at the data for different groups of countries, and they realize that there are some patterns, some similarities that we see when we compare the transition in mortality and fertility across countries. And this overall knowledge, this previous knowledge that we have of what happened first in more developed countries and then afterwards in less developed countries, we start to see that these patterns can help us create this major theoretical framework that help us explain these demographic changes. And this general theoretical framework that explains these major changes in mortality and fertility is called the demographic transition theory, right? We're gonna go more in detail about the demographic transition theory in the chapter about theories of demography when we go back to that. But here I just wanna give you an overview of the demographic transition theory because it's related to these changes that we have been experiencing in the world. So first, like this graph here is the one that we see in the textbook. And we are pretty much looking at the trends of birth and death rates in the vertical axis and then time in the horizontal axis. And we see that this graph is pretty much divided in these 4 stages. And in this first stage, in terms of a specific time point of some decades, some centuries ago, some countries had really high levels of fertility and really high levels of mortality. So birth and death rates were high. And this first stage, when you usually experience really high levels of mortality and fertility, is usually the pre-industrialization phase, the pre-industrialization stage. So that's the moment in our society, in our development of our societies, that we do not have so much control in terms of producing food. We don't have so much knowledge about health, about public health. And in this moment, the mortality levels are really high. The chances of children dying before reaching age 1 is really high. So infant mortality rate is really high. And at that moment, families knew that although they could have a lot of children, not many of them would reach adult ages. So as mortality was high, fertility was high as well. Of course, in this pre-industrialization stage, There was no contraceptive methods like the modern contraceptive methods that we have now. So fertility is also high because of that. But overall, since mortality is so high, families know that they have to have a lot of children in order to have at least few of them reaching adult ages. And it's also, there are cultural changes as well, right? In pre-industrialization phase, most of the populations are living in rural areas. In rural areas is actually good to have a lot of children because they help with the activities in agriculture. So children are labor for the families. And when we're going to talk again more about that in the chapter about theories of demography, but overall, the levels of mortality and fertility are really high. And then it comes the industrialization process, right? Industrial revolution, and then this modernization process, people moving to urban areas and having more access to food, better habitation or improvements on the levels, the life standard that people have. And as a result, we have a huge decline on mortality rates. So the chances of dying decline a lot. So life expectancy at birth increases. But it's still at that point, people were still used to have many children, and it was not yet so expensive to have many children and provide good education and good life standards for all of them. And at that moment, when mortality declines a lot because of all these improvements that we have in society due to industrialization, and fertility, birth rates, they still remain high, the number of births minus the number of deaths, the difference between these two numbers is really big. So because of that, we have a huge natural increase of population. So the natural increase, remember the basic demographic equation that we saw in chapter 1. It's pretty much we get fertility or number of births minus number of deaths in a specific country in a specific year. And if this number is positive, we have natural increase. If it's negative, natural decrease. And for natural increase, we are not taking into account migration, right? We're just talking about comparing fertility and mortality. So in this specific point, when we have industrialization going on and life standards, they improve a lot compared to previous decades, to previous generations, mortality declines, fertility still remains high, and the population increases a lot. And then we reach the third stage where fertility starts to decline. So in the third stage, fertility starts to decline, and because exactly what I said, because of urbanization, it starts to be more expensive for families to raise their children. And now the families realize that if they have 2 or 3 children, it's enough for them to reach adult ages, and because mortality is so low right now. So families realize that they don't have to have as many children because they will survive to adult ages, and it's also expensive to have many children. So birth rate, fertility, starts to decline. And as a result, the population as a whole doesn't increase in size as much as we saw in the second stage. And then we reach the fourth stage, where we have this incipient decline. In some countries, we even have more deaths than births in a specific year. So that generates negative natural increase or natural decrease. And other countries might still have more births than deaths, but the overall natural increase is not so high, right? So most of the developed countries are on stage 4. On the stage 3, Latin American countries are in between stage 3 and stage 4. African countries are in between stage 2 and stage 3. A lot of them already experience really a huge declines in fertility, and Asian countries also more towards stage 3, okay? But also, of course, that varies from country to country. This figure here is the one that's available in the textbook. And whenever in the exams or anything I ask about stage 1, 2, 3, and 4, you should report to this one here. The next one, it just subdivides the previous stage 3 here, where fertility starts to decline, into the stage 3 and 4. And I just like this graph from our World in Data. Our World in Data is that same website that I got graphs and data about the coronavirus pandemic. And I just like this graph here because it shows the trends of fertility and mortality. It shows the trends of birth rates and death rates, but also it shows the trends in population size, right? What's the total population that we have in overall in the world, and if you're analyzing this for a specific country, that's a good picture about it. So here in the vertical axis, birth and death rates per 1,000 people, and also under each one of these stages, it kind of summarizes what we see in each one of them in terms of birth rate, death rate, and natural increase. In this pre-industrialization process, really high levels of fertility and mortality. And because both of them are so high, population doesn't increase as much. Afterwards, during the industrialization phase, after in the Industrial Revolution, we have huge decreases in mortality, then much higher fertility than mortality. And because of that, we have a very rapid increase in population size, as we see here. And then on stage 3, fertility starts to decline, fertility starts to fall, and mortality, we still have improvements in mortality in terms of mortality keeps declining, but not so steep as we saw on stage 2, right? It falls, but more slowly than before. And because now fertility starts to decline and declines faster than what mortality is declining, the population is still increasing, but not as fast as we saw in the previous stage. In stage 4, in this figure is just a subdivision of stage 3 of the previous graph, and it's just a moment in which fertility keeps declining and the overall mortality is really low. We don't even see major changes in mortality, and fertility keeps going down, but still already at really low levels. And the difference in births and deaths is not so high as we saw on stage 3 and stage 2. So population increases, but not as fast as we saw on stage 3 and 2. And then finally, we get into really very low levels of fertility and mortality. In some countries, the overall birth rates are smaller than death rates, and you can even experience population decline, right? So in some countries, you can even see declines in population size because there are more people dying than being born, right? So these pictures, they give us an idea of these overall changes that we have seen in populations across the world in terms of decline in mortality followed by declines in fertility as a result of this industrialization and modernization process that we have been passing through in these last centuries. Throughout this analysis, whenever we are talking about population size, how much we are increasing or decreasing, in the textbook, it comes with this important demographic concept or pretty much a simple technique that we can apply to understand how fast or how slow a population is increasing or declining. And this doubling time is pretty much an equation that allows us to estimate how much time it would take for a population to double its size if the population growth rate maintained the same in the next years. So let's say that right now, the population growth rate in the US is 1%. So the population increases in 1% per year, or in a hypothetical country, right? That's a hypothetical example here. This population is increasing at 1%. How long time would it take for this population to double its size if it continued to increase by 1% every single year? And that's what this doubling time equation tries to explain, try to estimate that to us. So overall, if we have a population, the beginning of the period, let's say here population times 0, and we have the growth rate, the population growth rate that we have been experiencing in these last years, right? Let's say in these last years, I have seen in this hypothetical population an increase in the size of the population by 1%. Population growth rate equals 1%. So that's my R, it's 1% or 0.01, right? So 0.01. And I know that the size of my population has been, it was this previous year, 1 million people, right? So the question is, how long time, what will be T if this population with 1 million people and a population growth rate of 1% or 0.01, how long time would it take for this population to increase to 2 million people, right? So that's what we are trying to answer. So my population at the end of the period, what I'm trying to estimate is a population that would increase by the double, right? So this population at the end of the period would equal 2 times the population at the beginning of the period. So this guy here equals 2 times the population at the beginning of the period. The exponential of the population growth rate and the T that I will get here, this T here will be the time that it will take to jump from a population of this size to 2 times its size. And this equation here is just the overall equation in population growth when we realize that population grows exponentially. That's why we have this equation. I'm not going to go in detail about the equation because that's more the topic of another course, demographic methods, Sociology 320. But overall, we're just trying to understand the logic here. So in the 2 sides of the equation now, I have 2 times the population at the beginning of the period, exponential of the population growth rate, times the time that it would take to double the size, and the population at the beginning of the period. Both sides are multiplying by K0, by the population at the beginning of the period. So we divide both sides by K0. You just simplify to this. And the right-hand side of the equation, we have the exponential of the growth rate and the time. In order to take this off, I just take the log of the exponential and it just goes back into the original measures. The log exponential work in the same way as addition and subtraction, for example, multiplication and division. So I take the log of the right-hand side, I go back to the original units. But then I have to take the log of the left-hand side as well. I'm taking the log of both sides, and I simplify my equation to log of 2 equals the population growth rate times the number of years that it would take for the population to double in size. Since I want to answer this one here, I will keep it by itself on the left-hand side of my equation. This one is multiplying on the right, and just go to the other side, dividing. So I have log of 2 divided by the population growth rate. Log of 2, it's around 0.6931. Well, let's just say 0.7. All right, let's just round up here for this example. 0.7. In my original example, if I have a population with 1 million people growing by 1% per year, or 0.01 per year, how long time will it take to increase from 1 million to 2 million? How do I do this? 0.6931 divided by 0.01. Just rounded it up, 0.7 divided by 0.01, 70 years, right? So if I have a population that's increasing its size by 1% every year, or 0.01 to use the unit in this formula, it will take 70 years to increase from 1 million to 2 million, okay? And if we get a negative result for time, that's because my population growth rate is negative. In that case, this result of a negative time would be how many years would it take for my population to decrease by half? So that's the half in time. Pretty much it's just looking at the result. If time here is negative, that's because my population growth rate is negative, my population has been declining. How long time would take if this population here, 1 million people, is declining by -1% or -0.01? How long time would it take to reach 500,000 people? It would be the same 70 years, right? It's the 0.7 here divided by -0.01. So it's just the way that you interpret the t. If it's negative, how long time would it take for the population to decrease by half? If it's positive, how long time would the population double in size? Implementing this formula into the world example here. In 8000 BC, we had a population of 5 million people. In 1 AD, we had a population of 250 million people. So the growth rate equals 0.000489. How do I calculate this growth rate here? The same formula, right? I have here the population at the end of the period, the population at the beginning of the period, the time in between these 2 years, and then I get the growth rate, right? And then I implement the doubling time formula. If this population that increased from 5 to 250 million, which means this growth rate here per year, kept increasing by this rate, how long time would it take for this population to double in size? Or how long time would it take for this population to increase to 500 million? It would take 1,417 years. But that's not what happened, because in the following years, the world population actually declined in size, declined from 250 to 200 million by the year 600. So we have a negative growth rate. Implementing the doubling time equation, we get minus 1,878. What does it? 58. What does it mean? If the population keeps declining like that, how long time will it take for the population to decline from 200 million to 100 million? It would take 1,858 years. Why is this important? Because as you do this exercise for the following years, you start to see that the growth rate is increasing a lot. 0.0005, 0.001, 004, 006, 018, really high population growth rate. That's exactly because we start to see declines in mortality in stage 2, fertility is still high, then population starts to increase a lot, right? So in this case, let's say that we had a population of 2.5 billion in 1950, and it increased to 4 billion in 1975. So that gives us a population growth rate of 0.018 per year. Implementing the doubling time equation, it would take only 37 years, only 37 years. Look at this result before here. Only 37 years for the population to increase from 4 to 8 billion, right? And just to show this example here, let's just do this, try to do this in Excel to explain this really in detail how this calculations are done here. I'm just, the third column, I'm implementing the formula at the top of the previous slide. And the fourth column, I'm implementing the formula at the bottom, right? So let's just get here 1950, 1975. 1950, 1975. This keyboard is not. 2558. So 2558. I'm putting billions here. 4088. 4088. And we just look here. How do I calculate the growth rate? The growth rate, I have to get the population at the end of the period divided by the population at the beginning of the period. And I take the log of that and divide by time. So let's just see, time here, it's just 25 years. And I will get the population at the end of the period. Let's get the population, this one here, at the end of the period, divided by the population at the beginning of the period. I would take the log of that, just ln of that, 0.46, and then I will just divide this by the number of years in between. 0.018 is this number here, 0.018753, exactly what I got there. So here is the time in between. Here is KT divided by K0. Here is ln of KT divided by K0. And here is ln of KT divided by K0 divided by T. Right, so that's what I did here. Cool? So this minus this one divided by this, the log of this guy, and divide this one by 25, I get 0.018. How do I get the doubling time? The doubling time, I just get the log of 2 divided by this one here. And So let's just to get exactly the same number that we have in this slide, 37 years, okay? So I just calculate this one here first by knowing the population at the beginning of the period, the population at the end of the period, and how many years in between these two. Because this population grew from 2.5 billion to 4 billion in 25 years. What was the annual growth rate? That's why we had to divide it by T. That's what we did here. All right, this is how much it grew in 25 years. This is how much it grew on average every year. Of course, between these 25 years, some years it grew faster than others, but the average per year, 0.018. If it keeps increasing like that, the population will take only 37 years to grow from 4 to 8 billion. Is that clear? Why is this important? Again, to show how fast population is now increasing in size compared to previous decades, to previous centuries, right? Takes much, and the population is already very big, 2.5 billion, and here was only 5 million. And even now, when it increased from 4 to 6, from 75 to 2000, still high population growth rate, and would take 43 years if the population growth rate remains this one here, for the population to increase from 6 to 12 billion. But then we have been seeing some declines in population growth more recently, okay? So we pretty much use this formula here. Of course, we isolate the growth rate in one side of the equation. That's what I did in the Excel to calculate this one. And then we use this one here, pretty much this one, to calculate this column. Cool? And here in this next slides, I would just show data about population increase from different sources. They're all telling the same story, just different ways to show the results. So here, from that book by John Weeks, he kind of like put the years in which the population reached each additional billion. 1 billion by 1804, 2 billions in 1927, 3 billions in 1960, and so on. And then expecting 9 billion by 2040 and 10 billion by 2061. And of course, projections, like based on what we know about the past and what we think is going to happen in the future in terms of fertility and mortality rates. The annual growth rate was much lower in the 1800s, and then it started to increase. And as we already talked before, the annual growth rate got really high around the 70s, so 2%, the annual growth rate here. To put in that formula, it would enter this 0.02. And the annual increase in millions, how many additional people did we add into the world per year? 4 million in 1804, including this by this annual growth rate. And then it starts to increase, and we reach 75 and then 82 million additional people per year, considering these really high levels of population growth rate, okay? And as we expect people to, okay, mortality is improving, but it's not improving so much as we saw in the graph for demographic transition theory. And fertility is declining, still declining. So it means that we are not going to have as many babies in the world in the future. So we expect the annual growth rate to decline in the next decades, right? So the number of additional people added per year in the world will tend to decline, even though we're going to have more people. But fertility is going to keep declining, and then the addition of more people to the world will decline over time. This is a graph from our textbook showing similar things, the time points in which we reach exactly an additional billion, 3 billion around 1960s, 4 billion around 1975, 5 billion around 1988, 6 billion around 2000, 7, 8, and 9. 9 billion expected right after 2040. And these numbers from different sources, they might have some differences exactly because different demographers use different projection methodologies, and more important than that, different scenarios of how they think fertility and mortality will be in the future, okay? Another figure from our textbook. This is the annual growth rate. That's not the population size, the annual growth rate, how it increased a lot and reached really high levels in the 60s and 70s, and in the 80s was still also high. But then after the 70s, it started to decline. And the projections the United Nations has been doing lately, what they have to do is different scenarios. And the United Nations, they have the low variant, the medium variant, and the high variant. And basically, the difference between these variants is what we expect fertility to be in the future. Because mortality reached so low levels and is not varying so much, that what actually is the most difficult thing to do in terms of projections when we are talking about the whole world is doing simulations for fertility, right? So the low variant expects even sharper declines in fertility, medium variant just regular declines as we are expecting, and the high variant actually don't expect as much decline in fertility. When we do a population projection for specific countries, for specific continents, for specific states, it becomes even harder because of each one of these countries have a different context in terms of mortality. So it's not only fertility, also mortality. Fertility, of course. But then since we're not doing the projection for the whole world, we have to take into account also migration. So when we do projections for subunits of the world, could be continents, countries, states, and so on, then it's more difficult because it's not only mortality and fertility, but also migration. But overall, the projection by the United Nations for these next decades is that the annual growth rate will keep declining, right? It's not going to be zero, but it will keep declining. Population will keep increasing in the next centuries, in the next decades, but in a slower pace. And here, also from John Weeks, the world's population exploded in size, and we have here the population until the present time, at the time that this was published. And so here we have up to 2000. And also based on projections from the United Nations, the low variant, the medium, and the high. And in the low, we kind of making the simulation in which fertility would decline a lot. The population would actually start to decline much faster, already by 2040s. If we expect fertility to keep low and declining, but not so fast, we see that population will still keep increasing until 2100, and then we'll start to be more stable. And the high projection, in which fertility might not decline, it will, we would expect the population to increase a lot. Some of these simulations might not be realistic, such as the high projection, but they are just good to show us how much bigger or smaller the population would be if we just change a little bit how we expect the fertility will be in the future, right? Similar graph, this one from the textbook, data observed until 2010, and then afterwards, some projections, the medium variant in blue, the low variant in green, the high variant in red, and then the purple with constant fertility, where fertility doesn't decline. The total fertility rate will be constant from 2010 until 2100. So if fertility doesn't decline from the levels that we have now, population would increase to almost 30 billion people by 2100. But most of the projections are around 10, 11 billion, okay? By 2100. These two tables here, I did them based on the lecture by Hans Rosling. So showing the facts about population. Don't panic. Hans Rosling showing the facts about population. So where is this? This lecture is in our course website. So if you just go to our course website, it's at the beginning, this one here. Don't panic, Hans Rosling showing the facts about population. So here in specific point, he kind of shows how population would grow in the next decades. And I just created those tables here based on what he talks in that lecture. And here he broke it down by continent: America, Europe, Africa, and Asia. And whenever I talk about America, I'm talking about American continent. I never refer to America as only the United States. That's one thing that I'm not used to, I'm not gonna to. So America is the continent that includes North, Central, and South America, Europe, Africa, and Asia. So back in 2013, the American continent, Europe, and Africa had around 1 billion people. In Asia, 4 billion people, for a total of 7 billion people in the world. For these next decades, what do we expect? Because Africa still has high levels of fertility, some countries in stage 2 and some in stage 3, but a lot of them still in stage 2, fertility is still high. We expect the population to increase from 1 to 2 billion by 2050. American continent and Europe will continue similar, with not much variation in terms of mortality and fertility and even migration, right? The Asian continent, because so big and still some countries with high levels of fertility, expect to increase from 4 to 5. So to have a total of 9 billion people. And then by 2100, African countries still with high levels of fertility, we expect it to increase from 2 to 4 billion. And then the Asian continent stabilizes in 5 billion and reaching 11 billion by 2100, right? So this is showing that overall, based on how population has been increasing in these last decades, we kind of project what the population will look like in the next decades up to 2100. We don't expect the population to increase much more than 11 billion, right? After 2100, if you see all these other projections here, you see a stabilization in the size of the population, right? This one here as well, the median projection starts to stabilize in terms of size. All of them start to stabilize. Here we don't have 2100. They start to stabilize around 11 billion, okay? But what's gonna happen is pretty much the density of population density will change across the world. You start to have many more people living in Africa in the next decades comparing to other continents. And that brings up concerns to policymakers, to the government, to provide enough resources to this population that's expected to increase from around 1 billion right now to 4 billion in 2100. And if there is already problems of inequality, poverty in African countries, that issue is going to be even more difficult to deal with because of the bigger population size. But we know that's where we might go, and we have to start implementing policies to deal with this increasing population size in those areas. And then Hans Rosling, he does the same projection here, 7, 8, 9, 11. So the same 7 in 2013, and then 9 in 2050, and 11 in 2100, as we saw here. But now, instead of breaking it down by continent, breaking it down by age group. And Hans Rosling, he created this term, the child peak population. What's the overall number in total that we reach in terms of children or those people below 15 years of age? So based on all these projections, we don't expect the overall number of children in the world to be more than 2 billion. So we expect for the next centuries, for the next decades, 2050, 2100, to the overall number of children, those below 15 years of age, to be around 2 billion, right? So what's going to happen in these next years is pretty much these people here getting older and going to the next age groups, going to the next one, going to the next one, this one, the same thing, going here, going here, going here. Maybe this breaking down by age group and by years, they don't match correctly. I just used the material that Hans Rosling shared in his lecture, but it's just to give an idea that these people here, as they get older, they will just move to older age groups in future years. And this one's here as well, 1, 1, 1, and so on. So it's what's pretty much going on is that we're going to have, based on these fertility trends that we have, and also infant mortality and mortality of children below 15 years of age, we don't expect the number of children to increase too much more than 2 billion. So then you're just going to see these people moving up to old age groups through time. But one thing that we have seen, or at least we saw in this recent history, is still improvements in mortality, right? So we do expect that we would have at least around 1 billion people with at least 75 years of age by 2100. And that many people we had not seen before in previous years. But this one here is exactly because of improvements in mortality that we have seen in these previous years. Of course, now during the pandemic, I already showed you that estimation of life expectancy at birth for several countries in the previous class, that we see declines in life expectancy at birth because of the pandemic, which means increases in mortality. We have these variations, but overall improvement in mortality will make not only these people keep moving on to older ages, but you have an additional billion of people with at least 75 years of age. So it's just like a simple way to show how we expect population to grow. Population is growing from 7 to 8 to 9 to 11. It's not because we have a problem, a huge problem of really high levels of population growth rates that we never saw before. No, it's just because this number of people being born and reaching at least 14 years of age is going to be stable in 2, and they will just get older and keep moving up. And then we add Here we didn't have 2 billion. Now we have. Here we didn't have 2 billion. Now we have. Here we didn't have 2 billion. Now we have. Right? So it's just the generations moving up because they were bigger in size when they were born. So the world's population will continue to increase for the rest of our lives. That's what most projections they show us. Virtually all of it will take place in cities in developing countries. And we saw the population in Africa reaching 4 billion by 2100. The population reaching 5 billion in Asia by 2050. So exactly in developing countries, in African countries, for example, that's where we're going to see these increases in population size. And this is just one example of population increase, a projection from 2015 to 2050. And projection population increase in that period in overall numbers, right? So we have here from 1 to 13 million, 14 to 45 million, and at least 90 million people. And of course, because India has already so many people and their fertility is still high, we expect an overall huge increase in India in these next decades. But you also see in African countries, high levels of overall population increase. And you see population decline as well, for example, in Russia and Eastern European countries as well. But if we take these projections of population increase in percentage terms, that takes into account the population that you have right now, then you see that this percentage population increase will be much higher in African countries than in other countries around the world, right? And here, all these countries in Africa here, in orange and red, increasing by 63 to 121%, and from 122 to 260% between 2015 and 2050. Exactly because they have been experiencing improvements in mortality, all these improvements that we saw in modernization for other countries are now being experienced in a more larger scale in Africa. Mortality declines, but fertility is still high. You have this huge percentage population increase in that period, okay? Because in this case, I'm taking into account the population at the beginning of the period. When I take into account the population at the beginning of the period, you see that India, in percentage terms, is not increasing as much. But they will still add a lot of overall people in the world because they have a big population. This is the geographic distribution of world's population. And of course, we know that population is not randomly distributed across the world or even within countries. Russia more towards the east, the United States more on the western portion, and of course more concentrated also, in the eastern portion and also in the west coast. I said the opposite about Russia, right? The west of Russia is where we see more concentration of population. In China, more in the east. More kind of like well-distributed within countries in Europe, where you have more decentralization of services, of opportunities in those countries. But in less developed countries where opportunities, job opportunities, education possibilities for people are concentrated in specific cities, then you see in South America a lot of concentration in specific cities, and the same thing in Africa, right? And this is data from 2015. Cool. These are the 10 most popular countries in the world in 2015, and then expected projection by 2050. China, 1.4 billion. in 2015, expected to increase to almost 1.4. India expected to surpass China from 1.2 to 1.6. Nigeria expected to increase from 183 million to 400 million. So it's going to increase a lot. And that we saw in these graphs here, right? We saw Nigeria here, and we saw it also here, okay? The US declining in terms of the position, but the population also expected to increase from 325 to 400 million by 2050. And all the countries kind of like having also increase in population, but this overall distribution in terms of ranking will change over time. And this one is just a graph that I got from the Pew Research Center website, kind of showing the different placements of countries. And here we have Asian countries in green, African countries in orange, Europe in purple, North America in green or in blue, and Latin America in the Caribbean. I would say this is what? Darker green than this one here. This one is the lighter or the opposite. But overall, we see some changes going on there. But one thing that we compare 1950 and 2020 to 2100 is that here now we see many more countries in orange, many more countries from Africa. Nigeria, Congo, Ethiopia, Tanzania, and Egypt, right? And here, right now, we have only Nigeria. But again, India expected to be the country with the largest number of residents, and followed by China. But then we start to see a lot of African countries have really large population sizes in these next decades. Cool. Cool, so that was the lecture about world population trends over time. These next slides here, I will leave them as extra. And it's just from this other textbook, and it kind of like covers similar topics that we discussed here before. And it's just from this textbook here that I mentioned before, by Weeks, Population Introduction to Concepts and Issues. And, but yeah, so this third part, I take it as extra, and I will not be covering on quizzes and exams. So now starting on the next chapter about population change in the US. And here, just give you an overview of changes that we have seen in population in the United States. And then going a little bit more in detail, following the discussion in the textbook about major demographic topics in the United States. And in the textbook, there is a discussion about history of how family compositions were in previous centuries, in previous decades. I don't go so much in detail on that because I think there are some other interesting topics that we can take more time on them. But it does also cover these major demographic topics that we have been seeing in the US in more recent years. So that part of the historical family composition, I do talk here, but much more brief than what we see in the textbook. And in terms of these other topics that we will discuss, the United States is the country among developed countries with the highest levels of fertility rates. The United States is expected in these next decades to increase the overall number of people that don't self-classify as non-Hispanic white. So non-Hispanic white population is expected to drop to less than 50% of the overall population in the US And that's what demographers usually say. Now we will have a majority minority society around the year of 2044. If you get non-Hispanic whites and put in one side and get all the other groups and put the other side, they will be more than 50%. As I will keep emphasizing here, this term can be a little misleading because the other groups that are non-Hispanic white, there is so much heterogeneity among them, their experiences in the population, in terms of socioeconomic status and life standards and so on, that just putting them in this overall group kind of simplifies too much the whole complexity and diversity that the United States has in terms of population. But it's just an overall exercise to show that the proportion of non-Hispanic white will be lower than 50% in the world, in the US, in these next decades, okay? Knowing that the other ones, the other groups, they are really different comparing to each other, right? So it's just an example, an exercise to say that diversity is increasing in the country. There are changes of origin of undocumented immigrants. They used to be more from European countries and now more from Latin American countries to the US. The US has been experiencing increasing ages at first marriage. So people get married for the first time at older ages. Decreasing percentage of people marrying. Among those that get married, we have a decline in percentage of those people that decide to marry. Increasing levels of cohabitation. People, they tend to live with their partners before getting formally married or never get married formally. An increasing percentage of births to women who are not married. And I will just talk a little bit about these different topics here in these next slides. So the population in the US has been increasing a lot, exponentially, throughout these last centuries and decades. And this is data from demographic census in the US since 1790 to 2010, and reaching more than 300 million people for the first time using census data in 2010. The age structure, the age and sex structure in the US has also been changing over time. This is the age-sex structure in the US in 1950, and still high fertility. So we see still a large number of people between the ages 0 and 4. The interesting thing here about this age-sex structure graphs is, first, they show the colors in a little lighter for those who are children, 0 to 4, 5 to 9, and 10 to 14. Kind of a little darker for those in working ages, and the darkest colors for those with at least 65 years of age. Kind of showing, this is related to the dependency ratio, right? Children, working age population, and the elderly population. And it shows something else that usually some age-sex structure graphs don't show. Here we see among children between 0 and 4 years of age, we have more boys than girls. So we have this extra number here of boys compared to girls, this extra here. And what is this related to? Sex ratio at birth, as we discussed. Even in countries where there is no son preference, usually sex ratio at birth is above 100, so we have more boys being born than girls. So that's why you have here more boys than girls. As they get older, mortality rates are higher for men than for women, so this advantage starts to decline. And then when you get a little older ages, in this case here from 25 to 29, you start to see more women in this age group. Similar in these ones here that don't have the dotted lines, but in older ages, you see more women in each one of those age groups compared to men, exactly because mortality among women is lower than compared to men. 2017, you see a reduction in the number of children, right? So here we had a lot of children compared to older age groups. And now overall, you have more children, right? Here we had below 10 million for, this is in percentage, right? I think so. Or is it in, well, now I should check this out. But we have below 10% among boys and girls, and here we have around 10%. But that overall, no, so that's not percent. It's 10 million. Here we had less than 10 million boys and less than 10 million girls. By 2017, we reach around 10 million boys and 10 million girls between the ages of 0 and 4. But then the other age groups, you start to see a huge increase in absolute numbers, right? So all reaching at least 10 million for each one of the age groups in each sex group. It's the same exercise that Hans Rosling did, right? These children just keep going up, and mortality is improving. So those children that are born, they just keep getting older and going to the next age groups. And then projections to 2050, we start to see even larger numbers of people in older ages. And by 2100, really population aging going on in the United States. So again, these here are numbers in millions, okay, not in percentage. And this is the US population by nativity, and changes from 2014 to 2060. So pretty much nativity by dividing the population in those that are born in the US born or native born, and those born outside of the US, the foreign born population. By 2020, we have around 286 million people in the US who are born in the US, and around 48 million people who are in the US but were born in another country, and around 335 million people in total. And this 48 million out of 335 million, it's around 14% of the population, right? So you see an increase in the overall size of the population over time. You see an overall increase of the population over time. But you also see that the share of the foreign-born starts to be a little larger as we project the population for the next decades. So we expect that the foreign-born population will increase from 14 to around 19% in 2060. So that's 78 million people out of 417 million people, okay? So let's just show that we have an overall increase in percentage terms of people living in the US who are not born in the US expected for the next decades. This is the discussion that I said that I will kind of summarize. In the textbook, he goes more in detail about how families were organized in previous centers in previous decades in the US. I simplify this with this graph from Ruggles. He's the director of the Minnesota Population Center in the University of Minnesota. And the Minnesota Population Center is the one who organizes and make data available for census in the US, the American Community Survey, it's that survey that we have in the US for every year. And also we have data being collected by the Minnesota Population Center and make it publicly available to people from all other countries in the world. And the website that I'm going to talk to you guys when we discuss the sources of demographic data in following chapters. The website is called IPUMS, IPUMS.org, and it's created and directed by Ruggles. And I like this figure from one of his studies because it shows how families, they change their composition, or how he calls it, the economy, throughout the US history. So family economies change, or family economies of US couples between the ages of 18 and 64 changed between the 1800s and 2010. So what are those corporate families? Most of the families back in the 1800s, they were working in agriculture. They were small farmers. So families, the couple, and also with the help of their children, they were working with agriculture in their small pieces of land, producing and exchanging that in the market. And then we start to see a change in the mid-1800s, and then until around the mid-1900s, so around 1850 and 1950, you start to see an increase in the proportion of households in which the man works outside of the household and the woman takes care, works in the activity inside the household, right? So that's the male breadwinner style of family, in which only the man works outside of the household and the woman works inside. And I have children, so I completely understand that activities inside the household are much harder than work outside of the household, right? So I'm not saying that women don't work in this moment here. It's that they work in activities inside the household. But overall, in that time, 1850 and 1950, you see an increase in percentages of families in which only the man works outside. And then after that, when you start to see more gender equity, in which also the husband helps with activities, the chores for inside the household, and the woman, they go to college and they enter the labor market and they get a job and so on, you start to increase the proportions of household in which both men and women, they are working activities outside of the household. So the dual earner households, they increase in percentage from around 1950, and that's what we have now. The majority of the households now that we have in the US, you see, a majority of them, both in the couple, they are working outside of the household, right? One thing that you also see throughout this period is an increase in percentage also in households in which only the woman is working outside of the household and bringing resources to raise the family, right? That also increases almost 10% by 2010. And this figure, so as I said, Ruggles, he published in his paper back in 2015, but more recently, I follow him on Twitter as well, and he just posted it there because he gave an interview to that online magazine, The Atlantic, and he got upset with like what was the headline that The Atlantic did for that article, and for how pretty much the article was saying that we reach a moment in our society in which the family economies are not as good as they could have been. And that was, and Ruggles mentioned that that's not what he said in many of the interviews and later responses by email to the magazine. What he says is that population is changing over time, families are changing in the way that the couples work. And actually, this graph is showing a positive thing. Okay, you had a change in which in the pre-industrialization society, in which you still had a lot of rural activities. You had the corporate family, when the couple both worked in agricultural activities. Afterwards, you still have a lot of gender inequality, only men working outside. But then now you have this huge increase in the proportion of households with the couples, both in the couple working outside. And the interesting topic there about the female breadwinner households as well. Okay? So it's 12:25 now. I will continue on this chapter on Thursday. There is no quiz today. The next quiz will be on Thursday. Thank you very much, and I see you guys on Thursday.